This is the formula, though, that is basically, how do I say this? I guess that the calculations are following in the background, so to say. This is, in fact, the formula. I guess you could think of it as controlling everything. Basically, what's going to happen is this. We have this formula running everything. Notice there is an exponential function here, right? We have this here raised to a power. Okay, and the notation I put here, but A is basically the balance that we have after t years. Okay, it's the balance that we have after t years. PMT, I'm sure there's a good reason why it's denoted by PMT, but that's basically for us going to be the monthly deposit in this case. I mean, later on, we'll consider other situations, and for each one, we'll get a formula. But for now, PMT just stands for the monthly, the regular deposit. You know, how much you're putting in each month. So from the previous example, it would have been like $100. R is that interest rate, the APR, right? Just like from chapter 5, the annual interest rate. It's in decimal form here. N is how many compounding periods are done a year. So in the previous, previous example, N would have been 12. T is also how long we plan to do this. You know, how many years that is. Okay. And this is all, just division. I know you might not see parentheses normally like this. I'm just following the book's notation. I know the formula looks kind of bad. It's not as terrible as it looks. Essentially, the way to handle it is you want to calculate each piece at a time. I actually used Excel to help me calculate it. You can use Google Sheets also if you want. I mean, the formula is not in there, but you could do individual calculations easily. Now, and again, this is also something we're kind of, I guess, assuming throughout this chapter. If N, the compounding frequency, is not stated explicitly in the problem, we're going to assume N equals how many deposits are made in a year. So for us, it was monthly deposits in the previous example, and also, okay, it was compounded each month, monthly compounds, if that makes any sense. Okay. Now, this is actually, again, what they call the annuity formula, okay? And this is actually, how do you know when to use it? The reason I have the slide here is because in the chapter, there are going to be other formulas for different situations. And essentially, you're going to use this formula when there are many deposits. Okay? You remember, with compound interest, this is just a reminder from what we did in chapter 5, so to say. There, we put the money in there once and we leave it alone, and the money just sits there, and the account compounds the money, if that makes any sense, and you keep earning interest. But here, though, we're not only we have the money in there, but we're making monthly, many deposits, that is, on a regular schedule. Okay, that's what we're doing here. Okay, so let me do an example with this. All right. So this is just an example. It's not the same one as the calculations in the beginning, but it is similar though. So we have a special kind of retirement account. Usually with retirement accounts, this is what I think of. This is actually where you can't take the money out until you reach a certain age, because the money in that account is not taxed on. I have money in a savings account and that money is compounded. I also deposit into it monthly, but I do have to pay tax on the interest. With an IRA though, which is another account I have, I don't have to pay tax on that because I'm not taking any money out. So anyway, just a little background information, if that makes sense. Anyway, here we're assuming someone named Mary is depositing $100 a month. So she's making monthly payments, many deposits. That tells us we must use this formula, many deposits. Okay. and the account is earning 9% interest. This is our annual interest, okay? So the question now is, well, how much is she going to have in 20 years? Now, these accounts, they are compounded. But notice here, it never said how often it's compounded. It never said that. So we're going to assume it's compounded monthly. And why is that? Because she's making deposits each month. Although I know that explanation is right here, but I felt better saying it in words. Okay, we're going to use that formula, which is here. But, to use a formula, we need the parameters, right? Well, we're given her monthly deposits are $100 each. That's what PMT is going to be. Our R is 9% as a decimal, so that's 0.09. N is 12. Why is that? We're assuming it's being compounded 12 times a year. We want to know how much she's going to have after 20 years. So T is 20, and A is our unknown. Now, that's good. Okay, so let's figure out what happens. So this is the calculation I went through. I rewrote the parameters here, as you can see. What I personally would do, as you can see here, I kind of did it one step at a time. I did division first, then the exponents first, okay? As you can see. And then, of course, I added on top, raise that to the exponent and stuff, okay? But what's going to happen then is she's going to end up having, okay, $66,788.69. And again, that's after 20 years. That's what we have. Okay. Good. So that's what's going to happen here. Now, what's on the bottom here, I'll get to that in a second, but let me just say this though. Again, this calculation, you could do it in a calculator. You could. I mean, I don't know if you guys have a graphing calculator. That's a little bit easier to work with than the calculator I have in my iPhone. Although I did buy a special kind of calculator app for my phone. It makes it look like a TI-83. A TI-84, excuse me, that old kind of graphing calculator. It wasn't much. It was $6. It wasn't expensive. You don't have to buy it though. But you could do this in Excel. I'm not going to show you here in the lecture for time consideration, although it's really not that hard to do. But if you ever need help with Excel or Google Sheets, that's free to use. I know Excel comes with most computers. Google Sheets is a web-based one, version of Excel that is, and it's free. Okay. So if you need help with that, don't be afraid to ask me. It's not hard to do, actually. But this is how much Mary will have in that account. Now remember, not only is this coming from the monthly deposits, okay? No, excuse me, that's coming from the monthly deposits, but it's also, that's what I meant to say, it's also coming from interest. Remember how in that first example with the table, right? We were putting money in, but we were also earning interest at the same time. And that's really what this is saying. This is how much she has, okay? From here, how much she'll have. We're subtracting off how much money she's putting in. So this is how much is in there. We're subtracting off how much money she's putting in there, okay? And what's left over then is the interest that she earns. This is how much she earned from interest in that account. Okay, that's how much interest she earned. Okay, so the total amount minus how many monthly deposits she made, it was $100 per month, right? 12 months per year, and it's going on for 20 years. That's 240 months. So we end up with this. Okay. That's what's happening in this case. Okay, good. right, so that's good. All right. Okay. Now, let me just pause the recording, actually. The tool we're going to have to use. Okay. So let me just pause the recording.